natural log of e. Yeah, what'd you get? Yeah, it's 1. Why is that thing 1? Yeah, this is just log, right? The base e of e. So anything log base a of a, of course, has to be 1. So the natural log of e, of course, has to be 1. All right, you guys did pretty good on that one? Not too bad, right? Okay. All right, number 2. Who could factor that for me? All right, Andrea, what'd you get? Yeah, u plus 4 times u minus 1. You are totally, absolutely correct. We're going to use that later on in this lesson, so let's keep that off to the side, okay? Now, I'm using u's just because in calculus there is a technique that's called u substitution, and this is kind of along those lines, so I'm going to give a little bit a heads up on that. All right, here's what you have coming at you. We're going to solve problems 1, 2, 3 is where that u substitution comes in. Number 4, we're going to do something with natural logs. And number 5, we're going to need our calculators out. So that's what we're going to do today. And that's a gnarly problem on the left-hand side. So that's our goal, getting up to there. So let's start on number 1. I've got 5 to the 1 minus 2x equals 1 over 5. So what is the exponent on the left, the base on the left-hand side of the equation? 5. What's the base on the right-hand side of the equation? 1/5. If I could get those bases to be the same, then according to the most amazing fact ever, their exponents would be the same, right? So I'm wondering, could I change maybe one of those bases to look like the other? And I've given you a little hint on the right-hand side there. Anybody see it? Yeah. Yeah. Uh-huh. Yeah, exactly. So I could have 5 to the 1 minus 2x is equal to 5 to the negative first power, right? Yes, sir. You could also go the other way too. Yeah, yes, you could. Absolutely. So check it out. Now, are these bases the same? If the bases are the same, then we are allowed to equate the exponents by the most amazing fact ever. So that means 1 minus 2x, of course, is equal to negative 1. Now we're back in Algebra 1 land. So how do I solve this equation? Solve for x, yeah. So negative 2x is equal to negative 2. So x must be equal to 1. All right. So if I plug a 1 in, do I get the right answer? If I plug 1 back into the original problem, we get 5 to the 1 minus 2. Is that the same thing as 1/5? Yeah, it sure is, because 5 to the negative 1, of course, is equal to 1/5. We use laws of exponents. All right, what do you think about that? That one's not so bad, right? All right, here we go. Let's move on to number 2. So our goal is to solve 1/2 to the 1 minus x equal to 4. Now, in this particular case, I might want to have to change both sides, both bases, to come up with something. So, keep in mind the fact that 1 over a is the same thing as a to the negative 1. So if I changed both of the bases, could I get a 2 as a base in there somewhere? Anybody see it? Yeah, okay. What could the left hand be turned into? Left-hand side. 2 to the what? 2 to the negative 1, all to the 1 minus x, equals 2 squared. You guys with me on that? I'm not quite out of the woods yet. What do I do when I raise an exponent to an exponent here? I need to multiply them, right? Okay, so that means I'm going to have 2 to the negative 1. Now, don't forget to distribute this. So that's going to be negative 1 plus x is equal to 2 squared. You guys with me? Cool. All right, great. Now, are the bases the same? The bases are the same. So that means I can have negative 1 plus x is equal to 2. So x has to be 3. Huh? Which does work. Yeah, when you take the 3 and you plug it right back in for that, you end up that does work out. All right, so what do you think of number 2? All right, well, we got to think you're at stage 1. You don't get it. Stage 2, you kind of get it, or stage 2, you can knock this one out of the park, no problems. Or show me where you guys are at. I see some 3s, some 2s. Okay, alright, I see, oh, we're in between 2 and 3. Alright, good. Appreciate the honesty there. Alright, let's try the big nasty problem. This doesn't look like anything we have ever done before in this class. This is the strangest looking equation that we've ever tried to solve. And the method of solving it is even stranger. Okay, before we begin, I want to remind you of a concept here. If I said x to the third times x to the fourth, what would you do to simplify x to the third times x to the fourth? Daniel, what do you think, dude? X to the 3 plus 4, which of course is x to the 7, yeah. So if I had x to the m times x to the n, it would be x to the what? M plus n. Okay, that's going to come into the play right in the center of this problem right here. Okay? So we're going to go in reverse. Alright, here we go. I have 3 to the 2x plus 3 to the x plus 1 minus 4 is equal to 0. I am going to break this up into the going this way on my properties. So if I am adding the x and the 1 on the 3 for the exponent, then that means I could have multiplied 3 to the x times 3 to the first, because that would be this going in reverse. You guys see that part? Yeah? Really? Okay, cool. So then that means I'm going to have 3 to the 2x plus 3 to the x times 3 to the first minus 4 is equal to 0. That's the first weird thing that you do. Isn't that kind of weird, right? We've never done that before. Okay, now it's about to get stranger. But before it gets stranger here, what happens when you have, let's say, a to the m and then raise that to the n? What do you get? A to the m times n. You guys with me on that? So, notice I have 3 to the 2 times x. So, am I allowed to have this? 3 to the x and then quantity squared. Is that the same thing? It sure is, right? Okay. Plus. Oh, it could be. It could be that too, right? Well, I'm telling you in a minute. Okay. Times 3 and then minus 4 equals 0. That's the second bizarre thing that you do. And so far this is all like really bizarre. I'm like, where's this going, right? Now, I'm going to introduce to you a substitution. So check this out. I'm going to say, let u equal 3 to the x. And I'm going to put a big box around it right in the center there. Okay? Now, why the heck would I do that? Well, let's just go back to wherever you see a 3 to the x in the previous line, I want you to replace that with a u. So here's what I have. I have a 3 to the x, and then I'm going to square that, so I would have u squared. You guys with me on that? Plus, now I have 3 times a u. 3u. Then I have a minus 4, and I have an equals 0. And of course, this is the same as the warm-up, yes. So we've already factored it. But notice what we've done. We've done 2 crazy steps to sort of get us into a familiar happy place. Right? Oh, we're happy with that. This other step, super strange. So the method for solving this one is really bizarre, right? But we do it so that we can set up a factoring problem. All right, so since we have already done this problem right there, we factored in the very beginning. There's our warm-up problem. So we know how this factors. It's u plus 4 times u minus 1. So let's use that right now. This becomes u plus 4 times u minus 1 is equal to 0. You guys cool with that? So I have a polynomial times a polynomial equals 0, so I have the 0 product property, right? So here's what I get from that. U is either equal to negative 4, or u is going to be equal to positive 1. But that's not actually the answer, because what is u? 3 to the x, right? So if I replace this, I say 3 to the x equals negative 4, or 3 to the x is equal to 1, and the goal is to solve for x now. Okay, on the left-hand side, that's an extraneous solution, because 3 to the nothing will give me negative 4. Okay? So this ends up being extraneous. And 3 to the what power gives you 1. There you go. So x is equal to 0 is your answer. Isn't that crazy? That is a rad problem. That is a rad problem. Right over there. Rad. Alright, here we go. You guys ready to do this one? Alright, we have 8 to the negative x equals 1.2. 8 to the negative x equals 1.2. I've given you a hint as to what you should do first on the left-hand side. Take a look at it. See it? What's it say? Take the natural log of both sides. Really strange procedure. So, the natural log of 8 to the negative x is equal to the natural log of 1.2. Now I know you're going, why the heck would we do that? Well, doing that allows you to be able to use the properties of logarithms. Well, we could have done that too. It doesn't matter. You can pick any one you want. So the generic one is the natural log. Okay, so we do this because now we can bring that negative 8 down, or the negative x down in front. So I have negative x times the natural log of 8 is equal to the natural log of 1.2. And the goal is to solve for x. So if I just divide out natural log of 8, divide out the natural log of 8 on both sides, then I get x has to equal the negative natural log of 1.2 all divided by natural log of 8. So all we gotta do then is run this into our calculator, so I'll bring it up. Alright, so I'll turn it on, and let's punch in the negative natural log of 1.2. Push enter, so there's my numerator. And then I just divide that by the natural log of 8. Alright, divided by natural log of 8. I think the book wants you to round to 3 decimal places. So if I round that to 3 decimal places, I get negative 0.088. There we go. So I get negative 0.088 as an approximation. Alright, these are totally foreign, I understand. But not that bad. The only way you get better at them is just do a bunch of them and understand what you do as you do it. Alright, you guys ready for the big gnarly problem? Alright, here we go, the gnarly problem. Alright, I got 2 to the x plus 1 equals 5 to the 1 minus 2x. We're going to take the natural log of both sides first, just like we did before. So, the natural log of 2 to the x plus 1 is equal to the natural log of 5 to the 1 minus 2x. And again, we do that because we can now use the properties of logs. So I'm allowed to bring this down, say x plus 1 times the natural log of 2 is equal to 1 minus 2x times the natural log of 5. Let's go with that part. Alright, so now I'm going to distribute my natural log of 2 to the x and to the 1 because natural log 2 is just a number. So I'm going to distribute the natural log of 5 into there as well. So here's what I end up with. I end up with x times the natural log of 2 plus 1 times the natural log of 2 equals the natural log of 5 minus 2x natural log of 5. What do you think about that? Weird, right? Okay, what's the goal? The goal is to solve for x, right? So there's a piece that has an x in it, and there's a piece that has an x in it. And then the other pieces don't, right? This piece does not have an x, and neither does that. So I'm going to bring all the yellows to one side and all the blues to the other side. Okay? So then here's what I end up with. I end up with x times the natural log of 2 plus 2x times the natural log of 5 equals the natural log of 5 minus the natural log of 2 using properties of algebra. No, it's the natural log of 5 halves. Yeah. Okay, so now, check it out. Do you see there's an x there and there's an x there in both of my terms? So, I can factor an x out of that term and factor an x out of that term. So, that leaves me with this. X times the natural log of 2 plus 2 natural log of 5 equals natural log of 5 minus the natural log of 2. Okay, there's actually only 2 more steps. Who sees it? You divide by what? Yeah, exactly. You just divide out natural log 2 plus 2 natural log 5. Just divide this out. Natural log 2 plus 2 natural log 5. And we notice that this entire term cancels that entire term. So if we just run this part through our calculator, we have our answer. So let's go ahead and do that real quick. And I suggest you get the numerator first. So here's what I mean by that. Getting the numerator first. I'm going to punch in natural log of 5, and then subtract off the natural log of 2, and then get enter. And then just divide that out by the bottom, which is the natural log of 2. Natural log 2 plus 2 natural log 5. Close parentheses, and you should get the answer rounded 2 decimal places, or 3 decimal places, 0.234. So approximately 0.234. Yeah, sure can.